Hello everyone, welcome to my channel Cloud and Data with Koshi. So today our agenda is that we have to discuss about the Numpy. Very important, and this concept you must have to know this Numpy library, right? Whenever you working in a data science project or you are working as a data scientist, so you must have to familiar with this term Numpy for numerical calculation, numerical presentation. We have to use this library. Okay, so I hope I am visible and I am audible to all of you, right? If you have any doubts, so please let me know, and then we can start the recording. We can start the session. Okay. Yes, I am audible, right? Okay. So first, it's a hands-on demo session, right? And in this demo, I am going to use that Google Colab. Just let me share this thing. So you can see it's inside the Google Colab that where I can create, I can write my codes, I can write and execute the NumPy syntax, the NumPy libraries, the code syntax, and also either you can use this Google Colab, this environment, either you can use VS Code, either you can use Anaconda Google Cloud. So I hope I already have shown how you can install these different kind of settings, right? In my first or second video, I hope. So this video link description I will add inside this demo, inside this description box. Okay. So either you can use this Google Colab or either you can use your code space, right? So in your GitHub, you can see it's my GitHub account, right? In the GitHub, you have the code space. So in that mean, GitHub has provided your on behalf of you one virtual machine. On virtual machine, and from there you can execute your each and every comments over there regarding Python, Git, anything, Node.js, everything. So you can see this is my repository, and you already saw that YouTube channel recording. This is my base repository where I have to choose, and this is my branch name, and you can see machine type by default. This is 2 core, or this is two options they have provided, and that first option I am taking because NumPy library don't require the 4 core machine, is required for simple. I have to show some kind of demo, right? So as of now, 2 core is fine for me, and then you have to create your code space. You can write and you can click on the creating code space, right? Once you have in creating the code space, you can see setting up your code space. That means code space are being ready, okay? And you have this code space and your repository. This is the GitHub repo, okay? YouTube channel learning. So please fork this repository. So each and every session link I have added over there. So you can get that entire code syntax, entire file, right? Inside that. So I have already created the NumPy discussion. Here I have to add that IPONB file, and you can write your code over there. Okay. So just you have to click that NumPy session dot IP1B file, and then you can create. Okay. Now I have this code, or you can use VS Code. This is not an issue. Anywhere you are familiar with that, you can create. So this is the NumPy library and NumPy discussion folder, right? And you can see this is that my comment prompt is coming. So inside the main is my branch, and this is my you can write the PWD, and means present working directory. So this is my present working directory where I am going to execute my code and comments over there, right? So best practice, you can say you have to create the environment, you have to create that collab environment, and or you can create your virtual environment, then you can start your coding. Okay, because this is very pretty much standard use case. Okay, that I have followed. Is there any questions or anything? Please let me know so I can address this concern. As of now, I hope that you are okay with that. So, this today's agenda, I have to create, I have to discuss the Numpy library session. This is the today's agenda. Okay. I'm repeating this thing. So you will get the familiar with this concept. And that is from my side that today we're going to discuss the Numpy. Okay, so you can use anywhere, any platform where you can execute your Python code. You can execute your pip library, pip here you can use. So this is not an anywhere you can comfortable that I am repeating the same thing. Whenever you are comfortable, so please you can use that this platform. You can use that environment. That's not an issue. So you can use that. Okay. So I hope you heard about the NumPy library, right? I 1 minute. So if you have any questions, any doubts, so please let me know. So you can see you can use also the Google Colab that I told you. So go. I am I want to show this thing inside this code page, right? So you can create NumPy underscore session dot ipynb. Okay. So it's I have already everything is same. Means if you have create the replica in your own local system, right? You can get that. This is just a virtual system where I have to execute this thing. So I can create the ipynb file. Here you can write the print welcome to the NumPy session. You can write. Okay. So first time you have to install that suggested extension, right? So you can create over there. You can click and it will provide you that available Jupyter extension, right? You can see it will, you have to wait and then you will get that environment, right? You can see Python environment, Jupyter kernel and existing Jupyter server. These three options are there, right? So any one of them, like here I am using the Python environment, or either we can use that Jupyter kernel. So before starting from that, if you have any doubts, any questions, so please let me know. So I can discuss this thing. I can use this thing, and I can elaborate the concept, and I can provide you the good sessions, right? So if you have any doubts, so please let me know in your description box and in your comment box, or you can directly message to me. So that's not an issue. So I can definitely address your concern, right? You can write, you can just select Python environment and you can see you have that Python 3.10.30, right? So this is recommended. So you can use this thing. So Python 3.10.3, and you can see in the kernel that has been updated. Okay, it is executing. So this is my Python 3.10.13, this version, and this is the kernel, right? So you require one kernel to execute the commands inside this virtual environment. So you already seeing that my code is executed properly, and I'm getting that welcome to Numpy session. Okay, there is not, and if you have any doubts for creating this environment and inside the code space, so please let me know. So I can definitely add everything with you. Okay. Yeah, so step by step I'm going to discuss. I already have covered so many concepts of the Python, and then I'll after the NumPy you can get the sessions of pandas. You can get the image scraping. So there are many sessions already there. But today we have to concentrate. We have to focus on the NumPy session, right? So anybody tell me what exactly is NumPy? What is NumPy? So you can go in the official website. Just you can go into search box and you can write NumPy. Okay, this is the official website of NumPy. This is numpy.org. You can click this numpy.org and you can see. So it is always good that any library you are going to start, you are going to write the Python, you are going to add the matplotlib, you are going to add the pandas. So all the specific library, one thing you will be always have to see, that is documentation. We have to follow the documentation first, right? So everything is there inside the documentation. So this documentation page, it talks about what is the importance of NumPy, right? You can see the ecosystem, array library, everything is there, right? So there in data science, there are lots of numerical operations. Let's say in the machine learning, deep learning, anywhere you can go, you can get that numerical operations. Lots of mathematical operation involved over there. And with that mathematical that calculation, you have to use the NumPy. So clear everybody? So in that particular scenario, we need to really work with that arrays, right? List, triple, right? Arrays. You have heard about arrays, right? You you have know that matrices, that entire deep learning projects is all about that convolutional neural network in the deep learning, where you can see everything is the matrix and multiplication is happen inside that deep learning convolutional neural network. So it is always better that you have to use that numerical mathematical computation. You have to use the NumPy. Whenever you have the array of compression, right? Array of structure, array of expression, you have to use the NumPy. You have to use the multiplication, you have to use the addition of the array. So array is what? What is array? Anybody can tell me what is array? And if you tell what the data structure of array, so it's a homogeneous data structure. You can create different data type inside this array, but you have this kind of concept, right? The homogeneous data structure, non-homogeneous data structure. So whatever important thing, I will go everything step by step. So you have the clear idea, and you have to use the NumPy library lots in upcoming session in your entire projects of that data science, right? You have to use the NumPy. there are different data structure is there. So NumPy is one of the amazing library which you can play with that library, right? Clear everyone? Okay. So see the documentation. So reason I'm showing this documentation, if you have any doubts, if you have any good kind of understanding, so this documentation is very use case. Okay. And in Python library, the library that provides a multi-dimensional array object, right? And this, you can see NumPy brings the computational power of language like C, and fortune to Python, a language much easier to learn and use. With the power comes simplicity. So you can see one. So this is that array libraries, right? You can see. So NumPy's API is a starting point when libraries are written to exploit innovative hardware, create specialized array types, or add capabilities beyond what NumPy provides, right? So this is the ecosystem. So for your scientific domain, for your array libraries, for your data science, you can see everywhere NumPy is used. So NumPy lies at the core of a rich ecosystem of data science library, right? So you can see in this is the ecosystem, right? So you can use this NumPy library in different ecosystem, right? Scientific domains, you have the image processing, you have the graphs and networks, you have the signal process. So NumPy brings a computational power. So you have to use the multi-dimensional array. You have that multiplication, addition, subtraction. So that good kind of computational power of language like C, and that is the reason that I can say that NumPy is most popular one of the library in the data science, machine learning, visualization, array libraries. Everywhere we can use that library, right? So NumPy library. So if you have any kinds of good understanding, you can explore this numpy.org. This is the documentation, this is the official documentation. So you can get much more idea over there. So I hope you can understood. You can also see the case studies. You can also everywhere the NumPy library also be there, right? And you can also see the visualization part where NumPy is an essential component in the Python visualization language, which includes matplotlib. You can use Seaborn, you can use Plotly, you can use Bokeh, you can use Visify. There are different other names also be involved inside that visualization part. So you can see that NumPy accelerated processing of large arrays that I already told you, right? Large arrays, it will allow researcher to visualize data sets for larger than native Python could handle. So everything is documented over there. So if you have any questions, or if you want to get good kind of understanding, so please go and refer. I refer this documentation to all of you, so you can get the clear cut idea and what is the use case of NumPy and how we can use that. I hope I am clear this thing to all of you. So if you have any doubts, any questions, so please let me know. Okay, so you can see that we have to first you have to import the NumPy as NP. Okay, so I will also write this thing in my Jupyter notebook, or I am using the code space, right? So anywhere you can use, this is the starting point. You have to first add import NumPy as NP, then we can use and we can proceed further. Okay, so I am going this NumPy session, so you can write import NumPy as NP. As means alias. Okay. So what I'm going to import this library. What is the first statement? The first statement is importing the library. How to import? If you want to import the custom library, there is another class in another folder. This another class you have to import. That is there, right? So similarly over here, you have to import the particular package. So Numpy is already been installed, right? The answer is yes. This and this is installed this specific library. This is a core library of the Python. It's already been there. So import Numpy as NP. NP is nothing but alias. This is an alias. Okay. Alias basically means I'm not going to refer every time the NumPy. I always refer NumPy. NP. This is the alias. Let's say my name is Kaushik. And my name is Kaushik and someone is basically take me that KD. Okay. KD is my, you can see it's a alias. Okay. So this is short form. So they not always going to tell me the Kaushik and Kaushik they, okay. Instead of that, they can use KD. So KD is that alias. Okay. And every time you have to write the numpy in the code, right? So that is the reason I am using the as alias as NP. Okay, clear? Clear this concept, this thing. So you can use that. This is called a nickname, just kind of a nickname. Okay. So I'm going to execute, right? So you can use that. You can click this execute cell, so, or you can use Control Alt Enter. So you can use, and you can see NumPy is imported successfully. It has been installed. When you have configured the Python, that time it has been installed, right? And then you have to import. You can see an array object of arbitrary homogeneous items, right? That I already told. First, mathematical operations over arrays. This is the features. Okay, so you can use linear algebra, Fourier transform, random number generation. Everywhere you can use the NumPy. So next I have to take one list. So here I add 1, 2, 3, 4, right? This is my array, and you can add np.array. And you can see list will be converting inside in the array. And same element 1, 2, 3, 4 you can get. You can see same element you can get, but it's an array. List I have converting in the array. You can write np.array and you provide the list. This is my list. So this is my list. And whenever you are going to convert this list, right, in the array, so you have to just simple take np.array and you have to provide the list. So take array. np.array. So how I convert the list in the array? Okay, this is very simple. So it's already take. So tell me what is the difference list and array? So list are the collection of non-homogeneous element, and array is a collection of homogeneous element, right? List non-homogeneous element and array is the homogeneous element, right? And array is a multi-dimensional. So array is very fast to compare to list, and this is pretty much faster than list. So I have to going to store this value, right? So do one thing, you can copy and you can add. So now I am going to see what is the type of ARR. What is the type of ARR? So So you will just write type and add ARR, okay? So you can see is a ND array, okay? So in the Numpy, it will returning basically ND array, right? Slow and step by step, I'm going to provide, okay? So you have to take the list and you can convert the list to the array. You have to use np.array. So if I write ARR dot shape, ARR dot shape, I'm also writing the comments over there. Check the array type. So you can simply write type array ARR, and now I have to. So can I say it's an one dimension element, right? This is one dimension, right? So it can be one column or one row, right? It can be just one column or one row. So I can definitely say it's a one dimension array, right? So this is basically is in one dimensional array, right? Clear to all of you? So here please confirm yes, and you can write array. It's a one dimension. That is the four. That is why the four is there. Four element. There is no columns. So that is the reason they have used that only four. Now again, I'm create another array, right? So np dot array. Okay. And here I have taken two array. 3, 4, or you can take 1, 2, 3, comma, you can use 4, comma, 5, comma, 6. Okay. So is that the nested list? We've learned about this, right? I already told the list tuple in the previous session, right? If I execute this now, what I'm getting now? 1 minute is, so it will giving me 1 minute. I have make some mistake. You can see it's a two-dimensional array, right? So you can write, we have stored inside one variable. So I have provide this np.array inside one variable, that is ARR1. Okay, now let's check the type of ARR1. Just go and write type ARR1. And this is the in the array. Next, I have to check the shape ARR1 dot shape. Okay, so you can see 2, comma 3 is coming. Okay, so 3 elements. Why it is coming 2, comma 3? 2 rows, 3 columns, right? That is the reason it coming 2, comma 3. 2 rows, 2 rows, 3 columns. So you can write 2 rows and 3 columns. And what is how many dimension? And this is 2 dimension. And similarly, we can create 3, 4, 5, and 6 dimension also. Okay. So right now you have to focus this session. How I am create this array. I am use np.array. Inside that I have used the nested sublist. So first row I am in 1, 2, 3. Second row I am taking 4, 5, and 6. When I probably try to see ARR1, you can write ARR1. So you can see number of rows are 2. And how many number of columns are there? 1 row, 2 row, and this is 1, this one, 2, and 3. This is the columns, right? If I write ARR dot shape, so 2, comma 3. So first is 2 rows and 3 columns, right? This is rows. Horizontally, you can calculate the rows, and vertically you can say it's a columns, right? 2, comma 3. So this very simple thing, you have to grab the concept very clearly so you can understand this thing. Now do one more thing. And tell me in ARR1, how many numbers of elements are there inside the ARR elements? 1, comma 2, comma 3. So 6 elements are there. So can I check this same 6 elements are there? So this is 6 elements, right? Inside the array, 6 elements are there, right? So I also write the comment in this array, there are 6 elements are present. Is it true or false? Is it right statement, right? 6 elements, 1, comma 2, comma 3, 4, comma 5, comma 6. These 6 elements are present. This is nested array, 2-dimensional array. So in the array, we have 2 rows and 3 columns, right? We already have proved this thing with that help of coding, right? Array 1 dot shape. So you can see 2, comma 3. There is 2 rows and 3 columns, and this is a 2-dimensional array, right? And we have the 6 element. So can we prove that is also the 6 element are there in the other way? So you can write ARR1 dot reshape. How many total number of elements are there? 6 elements, right? And our dimension are 2, comma 3. So you can write 3, comma 2. Now I'm going to change the dimension 3, comma 2. 3 rows and 2 columns. Yeah. Yes, 3 rows and 2 columns. Now if I go and execute, you can see 3 rows and 2 columns, 1 rows, second row horizontally rows, I told you, and 2 columns. I have changed the dimension, right? So 1, comma 2, 3, comma 4, 5, comma 6. What does happen? What will happen if I write 3, comma 3? And because the total number of elements is 6 and 3, comma 3, it becomes 9. So it throws me the error. So always try to match with, you should always try to match with the total number of elements, right? You always try to match. Can I write 1, comma 6? Can I write 1, comma 6? What does mean 1, comma 6? Reshape 1, comma 6. So inside the 6 it will be okay, right? But not beyond the 6, because I have the 6 elements. So always check with the elements, right? If I hit, and you can create 1 rows and everything is inside the 1 element, right? 1 rows, there is no columns. And in the 2 dimension, you can see 2 double square bracket, and it will open the 2 doubles, it open 2 double square bracket, and it will complete or ends with 2 double square bracket, right? Is it clear? Does it make sense? So please let me know. Does that make sense, everyone? Right? So now we can understand what is the difference between one dimension and two dimension. Let's So we have the data set. Assume that we have the data set, right? Like we have the data set. So first feature is ID, second feature is name, and third feature is age, right? Assume that. So I have this value, right? Let's say I have 3 records, okay? So what will be the shape of the array if you're trying to convert this thing? 3, 3, right? 3, 3. That we can say we have 3 features, 3 rows and 3 columns, right? There is 3 rows and 3 columns, right? So I will add one more rows over there. Assume that this is the value, right? So in this data set, we also create another library with the pointers, but we have to create the concept of the numpy. 3 rows and 3 columns. So that is the reason I told that NumPy is very, very family image, very important. We have to know and we have to use that. Okay? You understand, you got this idea, right? So assume you are working in the real data set where you have the 3 features, right? And 3 columns are there. So if I reset 3, 3, right? You have the idea, right? Reset you just a particular element and you have reshape means try to change the shape in different rows, right? 2, 3, 3, 2, 1, 6. You can see only the 6 are coming, right? I can write 1, 6. Okay, I can write 2, 2 into 3. 6 is coming, right? 3 into 2, right? Or you can write 6, 1, right? 6 rows and 1 column. Just write. You can write 6, 1. So you can also write this thing as a 6, 1. So you can see 6 rows. Okay, clear, right? 1, 2, 3, 4, 5, 6. How many rows? 6 rows. So first we have to understand first we have taken the rows, right? And second the columns. So here I have only 6 rows and 1 column. So can we convert tuple also? We have already convert list to array. Can I convert tuple inside the array? Then write np.array. So you can write 1, 2, 3, 4. Okay, we can done. So this is the tuple, right? Can we do in respect to the dictionary this array, right? And in dictionary you have keys and values. You have to take the values out of it and you have to use that. Try to that use that. So use case of tuple. Okay, with np.array. Let's say here I have error1. Okay, just execute. So as of now, up to this point, you have understood this thing, right? Is there no confusion? I hope that. So I'll just wait 1 or 2 minutes, 1 minute, and then we can start from the new concept from there, right? So you have to understood we can convert list to array. We can convert tuple to array. We also can convert the dictionary. so that's not an issue. Okay, and you can see the reshape. You can see total number of elements we have to keep in mind when I am going to reshape, right? So suppose this is my array and I want to see the data type that array. I want to see the data type, this data. So you can write D types. If I execute this, oh, sorry, D type, not D types, sorry, typo. So you can see D type int 64. Okay. So whatever elements we have, this is the int 64, right? You can see data type. You can see the data type. You can see the data type of this array. This array. This is 64 means 64 bit. It depends on your system. So someone system it will show in 32, in my system 64. So this is an integer. Basically it's an integer. It depends on your system itself, right? Now we can see we can convert list into an array. And I'm not showing how we can create the array from scratch, right? How do I create array from scratch? In order to create the array from scratch, I can write something like this. You can write np dot arrange. Let's say I am seeing, right, 1 comma 10. So execute. And I am getting the elements 1 to less than 10, right? So this is my maximum element 9, 1 comma 10, and we can create this element. You can create the elements also. You can create elements with array. Now I'm going to write one more thing, that is np.arrange 1 comma 10, and you can write comma 2. So what is 2? So just execute, then I will tell you. So 2 is a step function, right? You can 1 plus 2. How much value will be coming? 3, right? You can see first is 1, and I have mentioned 1 plus 2, 3, right? Then I have mentioned 3 plus 2 is equal to 5, right? Then I have mentioned 5 plus 2 is equal to 7, right? And then I have mentioned 7 plus 2 is equal to 9. And here it will stop because my maximum element is 10. And I am starting from 1. So you can see 1, 3, 5, 7, and 9. So this 2 is a step function, increment value. I can I can add this value with plus 2, plus 2, and plus 2 in this way, right? It's a step function, we can say. We can add the steps. So if you can going to skip the every second element, right? You can go to 3, right? I am going to show you this thing also. You can also create your own array with this value, with these steps. Okay. I hope everybody is clear. I hope you are able to understand. Yes. Okay. So it's more like the skip it. You can skip this one value and then you can add. And tell me how many numbers of element you can see over here. How many? Can I do reshape this value? Can I do reshape? If I have to do the reshape, right now it's a single dimension, right? You can see. Right now it's a single dimension, right? If I write dot shape, you can see dot shape, you can see 5 comma blank. This is a single dimension. And I can also convert is that 2 dimension, right? And you can also check the, so I will add the comment. Don't worry, I will check, I'll provide all the materials, these code syntax to all of you. So just focus on the session. Don't focus the code or other things. We can distract from there, right? Now I'm writing, we can check the shape of this array. Okay. So this is 5 rows and there's no columns. It means five comma is there, right? And we can also convert 1 to 2 dimension. How can we do that? We can do that simply by writing this thing dot reshape. You can write dot reshape and you can write 5 comma 1 and now you can see 1 comma 3 comma 5. So this is one columns, right? You can see now I can write dot shape. You can write dot shape. Yeah. Okay. Oh, sorry, dot reshape and then you can write shape. Just a second. It's my bad. So dot reshape and then you can write to shape. So 5 comma 1. You can get the shape 5 rows and 1 column, right? 1, 2, 3, 4, 5 rows horizontally and 1 column that you can get. Okay. I hope you can understand how we can convert to shape to reshape. How can we check the shape? How can also with this value I can add this value. How do I create the array? You can write np dot arrange, right? Let's say I have the first elements 1 and 20, right? So we can create that up to 20 and I can write 2. So I can get this value. Okay, plus 2 plus 2 plus 2. Is this single dimension array? 1, 3, 5, 7, 9, 11, 13, 15, 79. So skipping the one element, right? Plus 2. And it will add this value. Everybody is clear over there? I hope everybody is clear, right? Is this single dimension? Yes, it's a single dimension, only one array. And you can also use dot shape. You can also check, don't trust with me, you can also check with the shape. So 10 comma. Can I reshape 2 comma 3 or 2 comma 5, right? You can also write dot reshape and you can write 2 comma 5 and you can see 2 rows and 5 columns. 1, 3, 5. This is 2 rows, 1 rows and 2 rows. 2 rows, rows means horizontally and columns is vertically, right? Rows is horizontally and 5 and columns vertically, right? Are vertically. If now I want to get the shape, you just copy and you can write and dot shape and you can see 2 comma 5. 2 rows and 5 columns, right? I hope everybody is clear still now. Is there any problem or any you cannot understood? So please let me know. 2 comma 5 enter element 2 rows and 5 columns, right? Okay, I hope you can understood. We can reshaping this value, right? Clear? And dot shape we getting this. I hope it's very simple and you can easily understood. How can we discuss that np dot arrange, right? Now see everybody how write np dot arrange, and I already discussed one concept, that is range, right? You can write range in the Python. Have you heard about this range? Range also does the same thing. You can write 1 comma 20 comma 2 and it will execute. It will also provide 1 comma 20 comma 2. And if I want to typecast or convert to a list, what will happen? So I will add the typecasting, that is list, and you can write range 1 comma 20 comma 2. Now you can see, okay, list. This value, I think, 1 minute. This function does not take the last element, right? Or just a minute, we can write np.arrange, np.arrange 50 comma 1. np.arrange, just a minute, np.arrange comma 1 comma minus 2. So you can see it will coming as a reverse order, right? I can alter the order from starting from the 50 and it will end 2, right? Reverse order, reverse order. And you just write minus 2 and it will reverse. And starting from the 50 and skip the second element, 48 minus 2, 46, 44, 42, 40, subtract. It will just keep minus 2, right? And this step size mentioned, right? And it will provide that 50 to ending to starting. That's reverse order. So let's say it's a one matrix. You can see. So most of the time we are working the 2 dimension, right? Okay. Let's see other examples also. Everybody clear with this, right? I hope we can understood the concept. Now we can discuss one more inbuilt function, np np dot linspace. You can see linspace. And this is super amazing functionality. If I want to quickly create an array between 1 to 50 or 1 to 20, and I want between 1 to 20, then equal number of elements. So let's say I want 40 elements. Okay, you understood? Let's say I have the scenario, I have created an array between 1 to 20, and between 1 to 20, we require 40 equal elements are required. Okay, now you can write 40. And you can see all equally spaced element, right? And just copy this thing and you just write dot shape and you will get 40, right? And you can also reshape this thing. So linspace is amazing functionality, this function, right? And you will get this thing. You can also reshape this. So if you want to create the equally spaced element, so I am also right, with the help of linspace, you can create equally spaced, equally spaced element, right? Over there, right? 1 comma 20, and within that 1 comma 20, 40 equal range of elements I want to execute. So you can use np.linspace, and you can also see the shape, and with the help of linspace you can create the equally spaced element, this thing. Okay, and also reshape this thing, just copy, and I am to break this reshaping, not reshape, that is 20 comma 2, and then you can see 20 rows and 2 columns. 40 is just nothing but total number of elements you want. When 1 to 20, how many how many types of elements? 40 elements, right? I hope you can understood this thing. So just next concept I'm going to discuss. So please, I hope you can understood this concept. So please let me know, and I'll just wait 1 or 2 minutes. If you have any doubts, so please let me know, then we can discuss this thing. Right? As of now is okay, right? You have good understanding of NP, this kind of concept. Lane space, reshape, save, arrange, this thing, right? So to wait 1 or 2 minutes and then we can start. Now you understood why 40 is coming. So you can see 40 equal elements are between inside 1 to 20. Lin space means linearly space. 40 elements between 1 to 20. Okay, I understood 40 elements. 40 elements between 1 to 20. 40 equally spaced element, linear space, lin space. That is the reason np.lin space I am going to use. Let's say you have scenario app, you have to create zeros, right? np.zeros. You can write np.zeros in that time. And if you write 5, so it will create 5 zeros, right? And then also you can write np.zeros, you have to provide the value, right? 10. And you can see 10 zeros are coming. So if I want to create 2 dimension, we can write np.zeros and you can write 3, 4. 3, 4. I hope you can understood 3 rows and 1, 2, 3, 4 vertically and horizontally 3 rows are created. I hope you can understood np.zeros. Everything is 0 and you have to create 5, 10, 5 zeros, 10, 10 zeros, 3, 4, 3 rows and 4. So we have np.zeros, then obviously we have np.ones. It will get ones. Simple. Just you can write np.ones. You can write 1 or 5. So 1. Same thing. np.ones. You can write 3, 4. And I can say one thing, every elements are coming floating point. And Numpy basically by default returning the value in the floating element. That is the reason 1, 1 point is coming, 1 point. So I can share 3-dimensional array, np.ones, and you can write 5, 8. You can see how many numbers of elements we have? 5, 2, 8. You can see, right? If I write 5, 2, 8, it represents the inner array. This is my inner array, right? This is 2 columns, 2 rows, right? And 8 columns, 2 rows, horizontally rows, vertically columns, 2 rows and 8 columns. 2, 8, first focus. 2 rows, 8 columns, 2 rows, 8 columns. If repeatedly I told 2 rows, 8 columns, 2 rows and 8 columns. And how many number of 2 rows and 8 columns I require? 5. Here I have 1, 2, this is one block, 3, 4, and last is 5. Understood? First 2, 8, and then how many times? How many times? 5. So this is a 3-dimensional array. You can see 3 opening and closing brackets are there. 3 closing, same, and the opening you can see 3 opening, right? And in the deep learning project, you can see that 3-dimensional array have used. the deep learning concept. There are many scenarios of 0 and 1s, right? And you have to use that thing. How can you reshape the 3 dimension? How much elements you have? How many total numbers of elements you have? And you can also reshape. You can what? Right? Clear this thing? I hope it's clear to all of you. What is np.zeros, what np.1s, and how can we provide the value? Can we do mathematical operation on this? Yeah, right? np.1s. So we can write 3, 5 is dot is just a floating number, right? Floating number. So by default floating, I write by default floating, right? I hope it's clear. Okay. If I will write 5 plus np.1s, what will happen? Tell me. np.1s. What will happen? So you can see 6. So 5 is adding each and every value, right? np.1s, right? 1 minute. 5 plus np.1s, and that is your 3, 5. 3 rows, 5 columns. Right? Ones mean 1, so 5, 1, 6, 3 rows and 5 columns. 3 rows and 5 columns. I hope you can understood. I am getting 6, 6, 6, and 6 and 6, 6.6 floating point, right? I hope you can understood. And this operation basically called it broadcasting operation. What is the meaning of broadcast? I hope you're facing the broadcast news, Doordarshan broadcast news, right? Broadcasting. In the Doordarshan, you could do broadcasting. The news is broadcasting. You can heard this term, right? Broadcasting. We have broadcast that information to everything. Whatever we are going to create, whatever operation, we have broadcast this thing. This is called broadcasting operation, right? So in respect to broadcast, we are going to do this, right? This concept is the broadcasting. Okay, I hope you can understood this concept. Broadcast, I hope you can understood. This operation is getting applied to the entire array, 5 plus. And guys, have you heard the identity matrix? Identity matrix. Does NumPy always give arrays? Tell me. Tell me the answer. This obviously this is the return type array is providing, right? It's very simple thing, but you have to understand this concept. What is identity matrix? All the diagonal elements are 1 and remaining value is 0. I'm writing all the diagonal element is 1 and remaining are 0, right? So in linear algebra, in concept of matrix of all, right? So you can use that thing. How can we create identity matrix in the np.I? Identity matrix you can write. So write np.I. If just write 4, np.I means 1 minute. I this thing, not I is my fault. So you can basically got that interlink, right? And you also create 6. So 6 cross 6 diagonal element will be create. You can write 6 and then it will also create 6 diagonal element. Can I reset this thing? Yes, yes, obviously reset. We can always do the reset method. That's not any problem. Let's do that. np.I 6.reset 12, 3. You can see 12 rows and 3 columns. So we also accepting or providing the reset in the identity matrix over there, right? You can see we can always convert this identity matrix. Okay, there might be one scenario we have might generate some numbers. While you are creating an array, I its identity. I basically means the identity. I repeatedly told this thing. I means identity, right? I and identity same. Let's say I want to generate some random values using the help of Numpy. How can we generate the random value? No value with Numpy. You understood, right? I hope you can learn something new. I hope you are happy with my explanation, whatever I'm going to explain this thing, right? So if you have any doubts, so please let me know in the chat or in the comment box. So obviously I will do that. It's my duty to solve your queries, to clear your doubts, right? So you may not have get out of that. You can take out maximum from this session, right? Yeah. In NumPy, something called as random. So you can write np dot random dot I. It generates the random number that rand. Okay. I'll just write the print statement random number generation. Random number generation, and this is uniform distribution, that is called, right? Uniform distribution np.random.rand. Okay, uniform distribution. What exactly the uniform distribution? So whenever we're going to start the statistics, that time I will discuss the uniform distribution. So everything will be discussed over there. So as of now, you can understood np.random.rand. You can write 2, 3. And generally, you can see randomly will generate the number in the 2, 3, and most of the time the value should be 0 to 1, and you can just execute this thing. You can say 0 to 1, the numbers in between 0 to 1. I hope you can understood. You can see np.random.rand 2, 3, and most of the time number will be 0 and 1. Most of the time the number is in between 0 and 1, right? And 2, 3 means 2 rows and 3 dimension. First is rows and 3 is columns, right? I hope you can understood. So I'm wait 1 or 2 minutes more. If you have any doubts, so please let me know, and then we can proceed step by step learning, and you can understood. So what we are going to do that thing, we can generate random numbers. This is the uniform distribution, and we generate the numbers. It will always giving the value in between 0 and 1. The next is, let's say I am going to create that numbers, right? We can create the random numbers. Just write print. You can write random number following a normal distribution. As of now, you can see normal distribution is bell curve method, right? Distribution. Here you can, as of now, you can understood mean is 0 and standard should be 1. With, you can write with mean is equal to 0 and standard deviation is 1, right? How can we probably create this array? np.random, right? You can write print np.rand random dot rand. If I go and probably add 5, 3, we can probably get that value. Okay. So I hope you can understood. The value is between 0 and 1. And all the values you can see follow normal distribution. 5, 3, 5 rows and 3 columns. 1, 2, 3, 3, 4, 5. Not ran, I will just ran in. Ran in for random and rand in. Rand in with the normal distribution. Please remember, I mistakenly write rand, but it should be rand in. Means random is a normal distribution. Rand in means random in with used with normal distribution. Normal distribution. You can also write. Okay. I just show you how to generate the numbers, but mean, mode, median, that will cover in the statistics part. Okay. Now you may be thinking, rand rand is inbuilt function. Randn is another inbuilt function is generates the number and following 0 and 1 with that normal distribution. Okay. Okay. I hope you can understood as of now this concept. So be patient, be practice at your end, so you can understood, you can familiar with that concept. Okay, you can understood this thing. Let's go and create one more thing. How can we create random numbers? You can write np dot random dot rand int 1 comma 100. Let's say add this thing, right? So it will given you number 1 and 100 and randomly. Every time it will change the random numbers. So it will provide execute this thing. So every time the number will be changed. You will see it's just changing, right? But the value is in value range is from 1 to 100. In between 1 to 100. In between 1 to 100. Okay, the value you can get randomly, it will change rand int. Okay, but the value range inside this 1 comma 100. How many numbers of element want? Let's say I have 10 elements. Just copy. So we can write and comma 10. And if I execute this thing, you can see 10 elements we can get. 10 is element. How many 10 here elements? Okay, but this value is 1 in between 1 and 100. Okay, you can see 10 numbers will be created, but value is in between. It's not exceeding the value of 100, right? 52, 19, 76, 59, all are inside this value 100, right? I hope you can understood rand int this method. Hope you can understood this concept. Yes, yes, everything I will add in my GitHub repository, and this link I will share in the description box. So you can get out of it everything over there, right? Okay, I hope you can understood. Clear this idea, clear this concept. I will create one more way, np like np dot random, and that is 1 comma 100, and you can write 4 comma 4. Okay, just click this thing, execute, and you can see 4 rows and 4 columns are coming. And I'm getting all the elements 4 comma 4. It will create that elements in this particular way, right? And it will create this array 4 comma 4. I will able to get this, right? 4 rows and 4 columns, but the number in between 1 to 100. That is this way you can also provide this value, right? Happy still now? Good idea you can get. New learnings you can get that. you have to remember all of the things by practice these things. But you have to work on this thing, you have to practice so you can get the idea. You can please be practice this thing and you have to understood this concept. Okay, that is the reason. Okay, so you have just put your efforts of learning and you can get the idea and you can get that concept very much clear and you can get out of it. Okay, so I hope you can get out of it new things, right? For today's session, new learnings you have expecting, and I hope you have met the criteria over your new learnings, right? I'm again wait 1 or 2 minutes. Then, if you have any doubts, please let me know, and then we can proceed further. In this way, we can start, right? Okay. So yes, yes, you have to work hard, and you have to achieve these things. Okay. We have to understood this. So just focused on the session and practice these things. That's why I've used random np dot random randint. I have used reshape. I have used reshape. I have used np dot arrange. So many concepts today I have discussed regarding NumPy. So you have to practice. Okay. I hope you can understood. So I wait 1 minute, then we can start. So I hope you have clear idea. So we'll state the next step. Okay. So randint is that you can see 4, 4, right? So you can see 4 rows and 4 columns is created over here, right? 61, this is a 1 rows. That is another rows. This is other rows, okay? So these 4 rows and 4 columns, but the range of value in between 1 to 100, in between 1 to 100. So you have the data, you have this value over there. You also create that random integer value. Okay, that is the concept. Okay. Let's start so you can understood. So I today just go slow because you if you have practiced this thing at your end, so it can helpful to while you are practicing with this session, right? And get most things from this session. Okay. So you can just revise these things. So many things I have added. Type, you can also see the shape, you can also see the array, you can also see the reshape. Okay, you can see random, you can see random, rand in, here used to normal distribution, and you can use that random method. Okay, so you can also create that identity matrix np.I. Okay, np.I.receive and 12 comma 3. So 12 rows and 3 columns. Again I am repeating. First comes coming the rows and second coming the columns. So here 12 is 12 rows and 3 columns are coming. So here in the receive and we have created 12 rows and 3 columns. And this is the identity matrix dot I. Okay, that we have created this value. And this is your np.random. You can see na np, when you hover on the np, so you get this numpy. We have provides how to use the documentation, so you can also get these things. Okay, so import numpy np, so everything I'm repeating. Okay, and then next concept I'm going to start. What will start that regarding the numpy, let's go and create an array np.arrange 0 comma 11, 0 comma 11. Let's consider in my array. And here basically I'm discussing one more concept, that is slicing. Slicing. Okay. So I want to get the element from 2 to 10. From 2 and 10. I want to slice. Slice. Slice the bread, right? So I have to chop that. Slice one. Okay, the concept is from there. So slicing the bread. So index will be starting with the 0. So index will start. So please remember, index will start from 0, 0 position. But here you also keep remember this thing, index in R programming language will, but index in R programming language, it will start from 1. Okay, first position. But in the Python, in other languages, we can say index will be starting from 0. And now we are going to slice. So 1, 2, 0, 1, 2, 3. In this index will come, right? Which index I will, if you just execute, you can get 3, the specific element, right? Now, if I want to get, means 2 is second index, right? 0, 1, 2. So 0, 1, 2, right? So just write up from 2 to last one, the element I want to get, right? So just add colon. Colon means rest of the thing. Okay. Yes, 2. Your array will be starting. Just a minute. You start np dot arrange. Okay. You forgot to add the variable. So this is your array. Okay. And then you can create this thing. And let's print the array. That means 0 to 10. And you have to use array 2. So it will come this value and array 2. And you can see we can take 2 to 10. Okay, this value. Perfect. Colon means rest of the last thing. Okay. So this is called the slicing method. 2 to 6. I want to get 2 to 6. Okay. So we 7 index, from 2 index to 7 index, from 2 to 6, from 2 to 7. We want to get the value. How you can get that? 2, 3, 4, 5, and 6. So up to 2 to 6, you will get the value. Okay. If I write here 2, if I write this thing -1, what does is basically gives me last element, right? 10. So if you want to get the last element, so you will add. If I want to get the last element, so basically I can add -1. So I will probably get the last element. Okay. And if I want to get that up to 7, so you can see what does this meaning. -1 colon 7 empty. So -1 to 7th element, 7 index, right? We cannot get this value. And we cannot give the empty value, right? If I give the third element, right, -1, right? If I will provide the third element, just go and you have to add this value -1. Okay. So what is minus this value? Which is the last element? -1. -1 is the 10th element, right? Element. Colon 7 is the 7th index. 7th index. And initially we got empty because this parameter is So by default, this value is 1, right? So if you can write minus, you can write this thing 2 colon 7, and you can write 2. So basically we'll get this value 2 comma 4 comma 6. So basically we get this value, right? If I make this as 3, then how can we get that? Right, 3 can change the value, right? We can copy and you add -1, and this value will get. This is called the negative indexing of the backside, right? Negative indexing. Okay. I hope you can understood the slicing. So you'll get the idea, the slicing method, right? The new concept I will also add as a heading, this slicing method. So no issues. We can add slicing. Okay. I hope this is clear to each and everyone. The slicing method. Let's do one more thing. Array -1 colon 3. What does it mean? If I get any output, why I am not getting any output? Increment of 1, right? Last element is 10, but 3. It will not work because the last element I will not go back forward to the third element, right? If I want to reduce the negative index, then we will get the value, right? Mine plus, right? I am going to can understood this 10th element -1 is my last element. Mainly means int value. Value string means value is 10. After that, I am going to insert 3 elements, but forward side, or if I want to go to forward, but forward side, there is no other element is present. Okay. Now that is the reason we are not getting any value. But as of now, we can understand these things. If I will add -1, so it will calculate from 10 and it will backward side coming, right? -1 means it will backward side coming, right? So I can use -1 and you can get the value. I hope now you can able to understand this value, right? If I will add -2, then probably we'll get the value. Yes. So 10 minus 2, 8, because there is here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is your value. And if I tell -1, that means 10, this value is coming 3. There is no positive side, means no forward side, no value. Forward side, forward arrow, you can follow the arrow, right? This arrow means forward side, there are no value. But, sorry, so in back side, if I come backward side calculation, I probably get the value. -2 means keep. So that means it will check previous mode. 10 -2, comma, for the value 8. So we can write 8 -2, 6, right? And you can add comma. You can add 6 -2, 4. Okay? And that is the reason your value is coming 10, 8, 6, 4. Okay? I hope you have cleared this idea as of now. Right? 10, 8, 6, 4, I told, right? 10 -2 and last index never be considered. Remember, last index will be calculated. And this indexing is very important and we have to understood, right? This slicing method is very important. This concept we have to master so we can go forward the other concept also, right? Shall we try some more concept? Now I'll try to two-dimensionally, right? Let's try to do that. And p dot arrange, you can arrange the value, or you can write np dot random dot randint. You can write randint, and you can write 2, 100, 20, and dot receive. And if I want to get 10 elements and 20 random methods, and I want to get the receive, how I can write the code? The value should be in between 2 to 100. Okay, and receive, you can write 5, 5 or 4. Okay, and let's say it's my array 1, right? So you have to pass one variable AR1 or array new. Okay, and now pick the 3 rows element. Okay, and make the slicing, right? How we can do that? I just want 3 rows, all the columns. Okay, I just want 3 rows, all the columns. How can we do that? This is my array new. You can see the value, 3 rows, all the columns, right? How many rows I want? 3 rows, right? 3 rows I want. 3 rows want. Okay. So how can we do 0 from 4? What is happening over here? So you can see. I wanted 3 rows by I getting 4 rows, right? So that is why I'm going to add 3. So three columns, three rows, and the first three record I want to get, right? The first three record. Okay. Tell me one thing. If I want to pick only three columns along with this, how we can do that? Okay, how we can do that? So let's do that. So 0, 3. So it will start from 0 and three columns, right? And can I write 0 column 3 also? So you can see rows separately and columns separately. You can see rows separately and columns separately. Indexing and separating for rows and separating for columns, right? So I add these two values, right? So this is, as of now, we have discussed. So if you have any doubts, again, let me know. Okay. This concept you also know. So we still now we have covered lots of things. So we have to apply the slicing method in the one dimension array, two dimension array. We have created the random methods. We have created the random integers. We have created the shape, reshape, many things, right? I want the elements, the last one. This one. 23, 25, 29, this four, this one, these four values, right? How can we do that? This value. How can we do that? How can we achieve this value? Tell me how we can do that. Should I wait 1 minute or just try? Let's try this thing. These values, this value I want. These values, right? So third rows, first I have to target the third row 0, 1, 2, 3. Third rows, right? So this is my third rows and second columns, right? And what will write? You can write array new and you can write 3 colon. So first target is we have to reach to the third element, third rows, right? Once we got that third rows, and then I want one and this value. You can see we have successfully subset this value, this element 33, 25, 29, 35, 55, and 66. Okay. So targeting the third elements first, targeting targeting the third rows. Okay, and next next column, and we used 3 colon comma 1 to here get the value. Okay, I hope you can understood. Every time is there any target position, right? Fourth row, fifth row, third row, second row. So you have to go there. Okay. So if I want to get 659 and 3325, these values, how I do that? Okay. Or if I want to get 33, 25, 35, 55, these values 33, 33, 35, and 55. How we can do that? These four values 33, comma 25, 35, comma 55. So write array name. Third rows you have to go, right? 33, 25, 35, and 55. 31, 20, 33, 25, right? Which rows? And this is which rows? 0, 1, 2, 3. These 3 rows, and that is your 2 colon 4. Now I want the middle rows, right? Now I want to the middle rows 1 colon 3. Just we got this up to that, and colon that is 1 colon 3, and you also get the value. Okay. Okay, third rows I told, right? Yes. So 33, 25. I'll get that. Or you can also get this. Any of them you can provide. Okay. I think or you can also write this check with other values. Okay. So I add array underscore new, and then I will write -3 colon -1 comma -3 colon -1. Yes. So we will get this way 6, 59, 33, 25. That I already told, right? These four values. This middle value 6, 59, 33, and 25. So you can also get this one. I hope it's easiest process we have to follow. The Numpy session. And I hope everybody has got the idea in respect to slicing, right? Let's wait again 1 minute. So if you have any doubts, so please let me know, and then we'll close the session. Just reminder 2 hours. So again, wait 1 minute and then we'll start. Sorry. So you have to practice very well this thing at your end, so you can get the idea. Repeatedly, I told you. Now, next concept is the universal function. Okay, some of the universal functions. So, right, universal function. Right. This is the last topic. And sorry for the session. I've just stretched this session. So, but we have to cover. We have to complete this thing or else. Okay. So, universal function. Hmm? So you write np.array, np.array, or you can write np.random dot randint, and here I will provide 1 comma 100 and 3 comma 3. Right? This is my array 1. And you can write array 2 is equal to np.random dot randint. You can see. So this is my array 1 and this is my array 2. Okay. 20 comma 100 and I write 3 comma 3. What we are do over here to execute this cell? So you have these two value, right? Just what did I do over here? Focus over here. What did I do over here? I created 3 comma 3 arrays, right? The between 1 comma 100 and that is 20 comma 100, and that is also called the matrix multiplication. So just array 1 into and array 2. First, let's check what is my array 1, how it looks like. Array 1, and another is that array 2. Now, if I want to add array 1 and array 2, want to add two arrays, is it possible to add or sum it up? Okay. Next, you also remember one thing, the shape will be the same for two arrays. The shape of the two arrays will be the same. Okay, the shape of the two arrays will be the same. So you can write AR1 plus AR2, AR2, right? So you may check you are successfully add the two values. Okay, you can write you can successfully add these values, add these two arrays value, right? So you can see array 1 36 and array 2 72. So it will add in this way. Okay, 36 plus 72, how much? 36 and 72, tell me how much? 108, right? 6 plus 2 8, 7 plus 3 108. So every numeric operation you can perform. Like I am using array 1 into means multiply array 2. Okay, so you can see it will multiply. It can multiply the array value. Okay, and also you can see array 1 slice or divide array 2. Okay, you can also provide this thing. We can also divide. We can also divide the array value. Okay, and also we can array 1 minus array 2. So you also get this value. We also divide. We also subtract the two values, the two array values. I hope you can understood all kind of plus, minus, sum, summation, subtraction, multiplication. This is called the universal function, right? Your two arrays shape will be the same. Shape will be the same. Shape will be the same. And in NumPy, last concept is that in NumPy there is also some inbuilt function. So I'm also write inbuilt function in NumPy. Okay. Just execute this cell. Yep, add these values. So you can also write np.sqrt square root. So if I will add the array 1, then it will provide the square root of array 1. Provides the square root of array 1. Okay. I hope you can understood. SQRT is the inbuilt. You no need to create this function. It is inbuilt of NumPy. Okay. Let's say basically exponential e to the power something. And here I am giving array 2. And each will take each and every element and it will find the exponential value, right? Clear these things, the inbuilt functions, e to the power, right? Similarly, all lots of inbuilt function, right? You can also write log 10 array 1. Okay, so you can also get this. So this is inbuilt function log 10 exponential value square root, the inbuilt function in NumPy. Okay, I hope everything is fine till now. I want to create one value, arrange, np.arrange. like I have 1, 10. Let's say it's my array, new array. Then if I want to see the value, new array, now I want to see this value. Okay, okay. What will happen? What will happen? After the 7 index, you can see every element will be the after the right, everything right after the second index, the value will be 1000. This concept is called as broadcasting. So you have different array function, right? So you can search in the numpy.org file in the official documentation. So there are lots of tutorials. You can go over the numpy.org. Okay. So please focus your official documentation part so you can get the idea. Okay. So everything is there. You can also documentation. Okay. Just a minute. It will come. So this is the documentation, the user guide. Okay. And okay, you have also one more function, that is dot operation. Just a minute. You can write in p dot dot in p dot dot, and you can write array1 or array2. Let's try to run dot operation, right? So you can see dot operation also work. Dot operation and multiplication also be there. So write matmul in p dot matmul matrix. This is called matrix multiplication. So you can also provide this to array1, array2, and your matrix multiplication also work. Now your matrix multiplication. So okay, this is all are inbuilt function. All are inbuilt function. So everything is mentioned inside your documentation page, and NumPy is a open source library. So please remember these things. Please remember. Open source. You can check in the internet. You can check at NumPy, GitHub. You can write and you can see. So okay. So you can see this is, you will go in the NumPy. Okay. So this is in this is the open source. These things you can also the GitHub. There is other GitHub communities. Numpy. Okay, I hope you can understood. This is the open source, and you also get the ideas, the user guide, augmentation, everything you can explore from this NumPy documentation, and you can get the idea and you can more explore. And I hope you can get some idea. And in this way, we just covered the session. I hope I can cover lots of things regarding to NumPy session. And please go and practice this thing at your end. And also please check that official documentation. And thank you for joining the session. Thank you everyone for joining this session. And please try to share, try to subscribe my channel, and in this way we can learn and grow together. Please subscribe my channel. It will, you can know in the live coding, it takes some time. Means it's really effort. It will take more efforts right from my side. So please subscribe my channel. So it will obviously boost my confidence, and I will definitely motivated and I will provide the new content more. So please and please, I definitely tell that please subscribe my channel. And if you have any doubts, so please let me know in the comment box. So I will add, and you can see this is my live, this the virtual environment, right? And in front of you, I will add a NumPy session. So you can get, so add this live, just it's your comment NumPy session code, right? And you have to comment. Once you commit, you can get this idea. Would you like to stage all your changes and commit them directly? Yes, because as of now I have one branch, so I can click yes, and you can see my repository is up to date, and I can sync changes, and then it will be push and pull. The flow will be good. Okay, and I will already checked in this thing. You can go in my GitHub repository and try, please try to fork this repository. Okay, so that will helpful for me. So you can write okay, GitHub, and please go to this repository, and this is my YouTube channel learning. In this repo I have added all the things, so please try to fork this repository, so it will help you and me both. Okay, and this is my NumPy discussion. You can see I have added the entire code in front of you, and also I can add this in the documentation, so you can probably go and download. Okay, so thank you everyone for joining this session. Thank you, and please subscribe the channel so it can motivate me. Thank you for joining this. Thanks.